Hi there. We're going to be reviewing functions. Let's do it. Here's a function. This function is the same thing as y equals 2x plus 6. This is the equation of a straight line. You can tell that because the power on each of the variables is 1, an invisible one. We know it's there. It's not some other number. Therefore, we have a linear function, which is a straight line function. All right, g of x is a code that we use instead of y. And what that permits us to do is look in the parentheses and know what number we're supposed to substitute for x. Excuse me. So g of 4 is 2 times 4 plus 6. And g of negative 3 is 2 times negative 3 plus 6. And g of 6.8 is 2 times 6.8 plus 6. Okay. I just looked up at the microphone to make sure it's on, and it's on. All right, 2 times 4 is 8 plus 6 is 14. 2 times negative 3 is negative 6, plus 6 is 0. And I'm going to use the calculator to calculate this. 2 parentheses 6.8 parentheses closed plus 6. Enter. 19.6. I want to show you I didn't have to do that. I could have said 2 times 6.8 plus 6. Got the same answer. 19.6. Okay. Now, we're going to do the same thing with f of x, which is the more normal way of seeing a function written. All right, we're going to find f of negative 2, f of 0, and f of 2. That means negative 4 times negative 2 plus 4. Negative 4 times 0 plus 4. Negative 4 times positive 2 plus 4. Now, when I calculate the answer, we actually have something very interesting. All right, negative 4 times negative 2 is positive 8, plus 4 is positive 12. Negative 4 times 0 is 0, plus 4 is 4. Negative 4 times positive 2 is negative 8, plus 4 is negative 4. Now, it just so happens, let me write the numbers up here. 12, 4, negative 4. I could make another column here if I wanted to. Sometimes it helps. This is the x, and f of x is the y coordinate of the point negative 2, 12. That's on the line. All right, 0, 4 is the point 0, 4. 2, negative 4 is 2, negative 4. Now I need to plot these points and graph a line. Negative 2, 12 would be negative 2. This grid only goes up to 10. We could estimate where 12 is, but might make a mistake. So let's not plot that point, but instead plot the other 2 points, because all you need is 2 points when you plot a line. 0, 4 is right here. The x-coordinate is 0. The y-coordinate is 4. Now, positive 2, negative 4, you graph like this, remember? You start at the center, and since 2 is positive, and it's the x-coordinate, you go to positive 2 on the x-axis, but you don't stop there. Don't even put your pencil down. Instead, move directly to negative 4 on the y-axis, or actually, it's easier just to go down 4 units, down because of that negative. 2, now negative 1, negative 2, negative 3, negative 4. Here's that point. Let's go ahead and label the points. 0, 4. Positive 2, negative 4. Now I'm going to graph a line. I have to do this because my lines are so wiggly. It's really embarrassing. It's not great, is it? But it'll do. There's my line. My line, right. Y equals negative 4x plus 4. Or the function f of x, the graph of the function, f of x equals negative 4x plus 4. There are some equations that are not functions, if you recall, and some that are. We use the vertical line test to tell which functions, well, which equations are functions, or which graphs are functions, and which are not. What I do is I draw a vertical line, my horrible lines. Let's make it skinnier. Anywhere through the graph. Notice that a vertical line through this ellipse crosses the graph at 2 points. This point and this point. So no, this is not a function. Why? Because it fails. The vertical line test. On the other hand, no matter where we put a straight line on this graph, this sawtooth graph passes the vertical line test. Why? Because a vertical line that I drew only crosses the graph, intersects the graph at 1 point. So yes, it passes the vertical line test. There actually is a much more mathematically stated reason for this, and we'll talk about it later. but not now. Because we're going to talk about a concept that can be difficult for students. We're going to write the domain and range of this graph in set builder notation and in interval notation. All right, so I'm going to write set builder notation and interval notation. Now, let's go ahead and review this. First, these open holes mean that x cannot equal -2. X cannot equal -2, which is the x-coordinate of that open hole. In the same way, x cannot equal 6. Since we're talking about the domain only concerns the x-coordinates of the graph, which means the domain is only on, or you can find it or graph it on, the x-axis. I'm going to make the domain blue. Now, x cannot equal -2, and x cannot equal +6, but it can equal every x-coordinate between these 2 points. That's a picture of the domain of the function. All of the x-coordinates of all the points on this line segment are located between -2 and +6 on the x-axis. All right, I'm going to come up here and I'm going to write the domain in set builder notation. All the real numbers are the numbers in our number system, and they are on the x-axis and on the y-axis. So we're talking about all of the real numbers on the x-axis such that they obey the following rule, namely that x is between -2 and +6, strictly between. Now in interval notation, I like interval notation so much more because it looks just like the graph, almost. -2, +6 with a comma in between. You can mistake that for a point, so you have to look at what you're doing. When you're indicating an interval of numbers, well, that's what the domain is. There are other intervals of numbers too. This is going to represent an interval. In fact, it's called an open interval because x cannot equal either of the endpoints. The range is on the y-axis. The range is the collection of all the y-coordinates of all the points on the y-axis. That is, all the y-coordinates of all the y points that are found on this line segment. So, I'm going to make that in red. What you do is you find the lowest point, and it's open. That means y cannot equal -5. And here, because we have an open circle, y cannot equal +1. Doesn't matter which way you make your slash. Okay, so I'm going to put a parenthesis here and a parenthesis here, and I'm going to graph the range of this line segment. All right, now the set builder notation is going to be all the real numbers y on the y-axis, such that y obeys this rule. It has to be located between -5, which is the lowest number, the lowest y coordinate, and +1, which is the highest y coordinate. Heck. Okay. Now the interval notation has parentheses. The lowest number is on the left, the lowest y coordinate. The highest y coordinate is on the right. Those are the endpoints, the parentheses, parens. Let's just say parens. The parens mean that y cannot equal -5 and y cannot equal +1. Okay, now we're going to talk about what f of 2 really means. This is our function right here. That is, this is the graph of our function. F of 2, remember, it's the x coordinate that goes in the parentheses. So I go to x equals 2. They want to know what f of 2 equals. This is what it equals. Watch what I do. I come to 2, it's +2. On the x-axis, I go down to the graph, and then I go over to the y-axis and see what that number is. That number is -2. So what the function does is it takes +2 on the x-axis and pairs it with -2 on the y-axis, and it gives us this point, 2, -2. That's what functions do. Now we can actually go the other way as well. And this is something you did not do in beginning algebra. You did this, but you didn't do this. What is x such that f of x equals -1/2? Well, this is y. So I need to go to x. Negative 1/2 is here. Let's make this bigger. Negative 1/2 is right here. It's already, it's on the graph. It's already on the graph. Go up to the x-axis, and what is that number right there? It's 0. X equals 0. So when x equals 0, y equals negative 1/2. When y equals negative 1/2, x equals 0. So my answer is going to be x equals 0. And what that tells me is that this is the point 0, negative 1/2. We'll be doing more of that. Remember, you can always back up and watch this part of the video or any part of the video again. Now, this is a graph you're going to get to know really well in college algebra. It's called a cubic. And we're going to do all those same things. We're going to find the domain. We're going to find the range. Okay, and we're going to use set builder notation. I have to learn to be consistent. After all these years, it may never happen. So, more things to remember first. Positive infinity is up here. Negative infinity is down here. Positive infinity is over here. Negative infinity is over here. The x and the y axes are both number lines that go from negative infinity to positive infinity. Now this graph goes forever to the left and forever to the right. So it takes up the entire x-axis for its domain. That's where it gets all its x coordinates from. It's so easy to write in interval notation. Never put a bracket around an infinity sign. Now the set builder notation, the way it's written in your book, is all x such that x is all real numbers. The real number system is the name of our number system. So all real numbers means all the numbers on the x-axis or all of the numbers in the real numbers system. They're the same thing. The range, well, look at this. This is easy to see. This graph goes up forever and down forever. So the SBN, set builder notation, is going to be all Y, such that, no, wrong color though. There's no rule that says the domain and range have to be different colors. I just think it makes it easier. All Y such that Y is all real numbers. Well, B-E-R-S, don't tell anybody. Meanwhile, the interval notation. There's a mosquito in here. Negative infinity to positive infinity. These are not the same. This is on the x-axis. This is on the y-axis. All right, now we're going to go on a hunt. What is f of negative 1? I don't know. Let's look. F of negative 1. See, I guess I should put it in red. These should have been in blue. Don't tell anybody. We'll keep it all in black. Here's negative 1. I go down to the graph and then over to the y-axis. That's negative 1. So f of negative 1 is negative 1. And that gives you the point negative 1, negative 1, right here. No room to write it. F of negative 2. These are the x-coordinates in the parens. Here's negative 2. Go down to the graph and then over to the y-axis. That number is negative 4. That gives us the point negative 2, negative 4. Now, what is f of positive 2? Go over to positive 2, up to the graph, over to the y-axis. 2 gives us the point 2, 2. I do have room to write it here. This point is 2, 2. And I could have written this point, negative 2, negative 4. Okay, now f of 4. 1, 2, 3, 4. Go up to the graph. 4, go up to the graph. Over to the y-axis, we have 8. So this will be the point 4, 8. And then finally, f of 0. I always had trouble with that when I was a student. Here's 0 right here. And look at what the y-coordinate is there. 0. So f of 0 equals 0. This is the point 0, 0. The origin of what's called the Cartesian coordinate plane. Remember that? And we're done with this very, very brief review of what you learned in beginning algebra and then a little extra just to keep you interested. Talk to you later. Bye.